Okay, these are today's notes. They are on section 10.2, which is log functions. When I'm done with these notes will go into our class notebook under Unit 10 materials, just like you always will see in the content library. So we talked about exponentials, and now we're talking about logarithms, which are just another way of rewriting an exponential. So in exponential form, we have b raised to the a equals x. So b is your base, a is your exponent, and then x is your number. Both the b and the x have to be a positive. Okay, must be positive. The exponent can be whatever it wants to be. When we rewrite these in log form, logs will actually allow us to solve equations that used to have the variable up in the exponent. So when we rewrite those, we have to make sure, again, that the base number b, this little number here, and then our number x right here, those, again, both have to be positive numbers. Must be positive. And then again, our exponent can be whatever it wants to be. So we can interchange those, and what you may remember from the past is, at least this is how I always teach it, to rewrite it into log form, you start with the word log, and then it's base b of x equals a. And it kind of makes these arrows, which reminds me of a recycle symbol. Then when you're in log form and you want to switch it into exponential form, you start with the b, raise it to the a power, and it equals x. So it's just a way to rewrite it, whether you want the power in exponential form or you want the log if it's in logarithmic form. Just some general notes, the information right here, I just talked about that. That's just telling you how to define the different numbers that are in a log or an exponential. Second bullet point is about common logs. Common logs are logs base 10. So you guys might notice on your graphing calculator or really any scientific calculator, you'll see a button that just says log on it. Log means a log of base 10. So that means log with a little 10 down here. And they don't write the little 10 because it's the common log. It's the one that's always used whenever we're doing anything with a base 10. They just call that a common log and write the word log. Natural logs have a base e, and we write that as ln. So you have a button on your calculator that says ln, and that's just taking a log with a base e, and then e is that number approximately 2.71828, blah, blah, blah. That number is used commonly in interest formulas and things in like economics and all kinds of stuff. But that's a number that pops up a lot. So since E is also a power, you might remember like interest equals principal times e to the rate times time. That's an interest compounded continuous formula. I think I'm off the screen there. Whoops. Okay. Compounded continuously. That's a formula that you guys probably learned last year. But E is that number. It's kind of a number like pi. It's an irrational. It just is a non-terminating, non-repeating decimal. So those are two buttons that you have on your calculator, and we will be using those when we start evaluating. So this next section we have, it's given exponential form and we're writing it in log form. Something that's important is to actually read through the directions and, are you answering the question? When it says write it in log form, what word should be in my answer? The word log. So I will write down log, and then this is our base, log base 5. Then you skip over the exponent and you go of 25 equals, and the exponent goes last, 2. So that follows from what we did up above right here. We're just modeling this. They're giving you exponential form, so the b, a, and x go back into the log form, but in a different order. 2, we're going to write it in log form, so I need the word log. My base is 6 of 1 equals 0. I'm just rewriting the format. Log base 3 of 1 over 9 equals -2. And I just draw these arrows. That just helps me organize. Log base 3 of 81 equals my exponent 4. Log base 8 of 2 equals 1/3. And then the last one, it's going to go log base 2 of 1 over 32 equals -5, your exponent. So that's going from going from exponential form into log form. When you're done, you make sure all of your answers have the word log in them. And then I like to check, I'll take like one of them and I'll check it by just doing the reverse. So I'll draw the arrows again in exponential form, like number 6 would have gone 2 raised to the -5 equals 1 over 32. And if you get back what your original problem was, you know that you did it correctly. All right, I'm going to pause and post.